Hey guys, this video goes over your midterm week CR. Some of the numbers jump around a little, so don't let that throw you off. If you have any questions, let me know. Start with number 1. So find the average monthly high temperature in Buffalo can be modeled by the function b of t, where t is the month number, January is 1, state to the nearest tenth the average monthly rate of temperature change. So as soon as you see rate of change, that should make you think slope. And remember that slope is y2 minus y1 over x2 minus x1. That's the slope formula, right? So in order to come up with a slope here, we need to find two coordinate points. And I'm going to do that by using my calculator. So I'm going to type this function into y equals, and I'm going to go to the table, so second and then table, and I'm going to get some coordinates out. Now, I want to go between August and November. In other words, I want to look at when my x-coordinate is 8 and when my x-coordinate is 11. And if I do that, I'm going to get that my x-coordinate when it's 8 is 78.903, I believe that is. A little hard to read my handwriting. Or 932, sorry. No, 903. And 11, it's 48.732. Now, if you're not getting those values out, I want you to check your mode. Remember that you need to be in radian mode. So using those, I'm going to plug that in. It's going to be 48.732 minus 78.903 over 11 minus 8. And remember, y1, x1, those should go together. And that gives me to the nearest tenth, which is what they asked me for, negative 10.1. Now it asked me to explain that and give it in context. So let's look at our units. The numerator has a change of units of degrees Fahrenheit. The denominator has a change of month. So my units here are degrees Fahrenheit per month. And so think about what that means. That means on average, the temp is changing, or the temp is decreasing at 10.1 degrees Fahrenheit per month from August to November. Okay, so units can be a big giveaway there of what we actually need to know. Okay, let's look at this next one. Number 2, when g of x equals 2 over x plus 2, h of x equals log, and notice there's no base there, that's a base of 10. Log of x plus 1 plus 3 are graphed on the same set of axes. Which coordinate best approximate their point of intersection? I would not leave this to chance. I would not leave it to plug in. I would plug g into y1, h into y2, and you're going to get a graph that looks sort of like this. And we are looking for their point of intersection, which would be right there. So you are going to hit second, calc, and then 5, which is intersect. And when you do that, you get x equals negative 0.9269206 and y equals 1.863795. And looking at which one that's actually closer to, that's closer to answer choice 2 if you actually round them. Notice they put those answers very close together to see if you actually knew how to use your calculator to find those. Now, if you need help with doing that on the calculator, again, go back to my calculator one. Okay, next one. Aaron and Krista were working on a cubing binomials for math homework. Aaron believed they could save time with a shortcut. She wrote down the rule below for Krista to follow. Does Aaron's shortcut always work? Justify your answer algebraically. Now, it does not say justify your answer, period. It says algebraically, which means we need to do algebra. So I want to prove that this equals that, or that it doesn't. So what I'm going to do is pretend that the right side doesn't exist, and I'm going to expand out the left side and see what happens. So cubing it would mean a plus b, a plus b, a plus b, and let's see if we get that answer. Now, when you multiply three things together, remember that you need to multiply the first two together first. So that's a squared plus 2ab plus b squared times a plus b. And then from there, we're going to multiply again. And so when I do this, remember that we're distributing each thing out. So a squared is going to get multiplied each of those. So that's a cubed plus a cubed b, or I'm sorry, a squared b. And then I'm going to multiply these out. So 2ab times a is 2a squared b. And then 2ab times b is 2ab squared. And then I'm going to multiply these out. So that's ab squared plus b cubed. And you can combine your like terms there, but I can tell clearly that does not equal a cubed plus b cubed. Notice that this is a yes or no question, so the answer should be no. Make sure if they're asking you a yes or no question that you're also answering yes or no there, right? That is going to matter. Okay, let's move on to number 5. So 5 and 6 are both system of equations. 5 I see is a 3 by 3, and when I do these, I like to sort my paper sort of into 3 columns. So in the first column, I'm going to do the initial elimination. Second column, I'm going to do my final elimination. Third column, I do my substitution. So I'm going to start by eliminating, let's start with the first 2. So I'm going to use equation 1 and 2. And I'm going to multiply the second one by -1. So a plus 4b plus 6c equals 23. I'm going to multiply my entire second equation by -1. And then I'm going to combine that by adding down my columns. So that's going to come out to be, let me actually slide this over just a hair. There we go. So that's going to combine to be, these are 0. This is 2b. This is 5c, and this is 21. So there's my first equation that I will use. And that's going to be the first equation I bring over into my second column. Now, for the second 2, I'm going to choose 2 other equations. So I'm going to use 2 and 3. And notice in the third one, a is over here. So I'm actually going to move that over. So this will be a plus 2b plus, or actually I think I used 1 and 3 on my key. So let me do that. So a plus 4b plus 6c equals 23. Negative a plus 6b plus 2c equals 14. And then I'm going to add down. So 10b plus 8c equals 37. And it wouldn't have been wrong the way I did it before, but I'm just trying to stay consistent with what I did on my answer key. So now I'm going to take those and bring those over to here. So I've got 2b plus 5c equals 21. And I've got 10b plus 8c equals 37. And now notice I'm down to just 2 equations, and that is the skills we need. Or I'm sorry, that's an Algebra 1 skill. So I'm going to just leave the second one alone. I'm going to multiply the first one by -5 to get my b's to cancel. So this will be -10b minus 25c equals -105. And this will be 10b plus 8c equals 37 again. And so adding down those columns, I get -17c equals -68. Divide both sides, so c equals 4. Now, sticking in this column, I have these equations where I have just 2 variables. So I'm going to pick one of those and plug c in. So 2b plus 5 times c equals 21. That gives me 2b equals 1, so b is 1/2. Now on the regents, typically we won't come up with a fractional answer. On this one we happen to. And now we're going to plug those both back in to any equation and see what we get. So a plus 4 times 1/2 plus 6 times 4 equals 23. And so a equals -3. So my solution will be a coordinate point -3, 1/2, and 4. The other thing that I would urge you guys to remember with this is if you need to look back at this, go back to my Unit 1 live stream. It's in there, right? Good. Okay, next one is another system. So solve this system algebraically. Notice this does not look like a good candidate for elimination. These don't just straight up line up. And so when I see that, I'm going to go to substitution. So I'm going to go to this bottom equation because that one's a little simpler. And I'm going to get y alone here. I'm going to subtract 2x and add 6. And then wherever I see a y in this equation, I'm going to plug y in there. So this is going to wind up being -2x plus 6 plus 2, because remember this is y plus 2, equals x minus 4 squared. So now this is all in terms of one equation, or sorry, one variable. So now I can solve this. So on my left side, I can combine some like terms. And on the right side, I can multiply this out. And again, I'm just doing double distribution here. You can also use the box method, whatever you need to do. And with a quadratic, remember that I want to get it equal to 0, so add 2x to both sides, subtract 8 from both sides. So I wind up with 0 equals x squared minus 6x plus 8. Pretty easily factorable, or you could use quadratic formula, but x minus 4x minus 2. And so I wind up with x equals 2 and x equals 4. Now remember, for a system of equations, you should have a coordinate point, right? So those are going to matter there. Now, from here, we're going to go back and we're going to plug in. So if I plug in my 2, right? If I plug in 2, then I'm going to wind up with y equals 2. If I plug in 4, I'm going to wind up with y equals negative 2, and so that would be my solution to my system, those two coordinate points. Next one, Tony is evaluating his retirement savings. He currently has $318,000 in his account, which earns an interest rate of 7% compounded annually. He wants to determine how much he will have in his account in the future, even if he makes no additional contributions. Write a function and graph it on the interval from 0 to 20. So let's start with that. I'm going to pull in my finished graph here so we can look at this. Voila, through TV magic, here's our key. So I have 318,000 as my initial, 1.07 to the t because it's growing by 7% per year. And I'm graphing it. So notice I'm counting by a nice even amount. I've labeled my axes. I'm going all the way to 20, counting by 1. And then here I'm counting by 100,000s. And I'm getting these values off my table. So graphing those, his goal is to save $1 million, determine algebraically how many years it will take for him to achieve this. So I am setting that equal to 1 million. I'm dividing both sides by 318,000. I am converting to a log, and that would be algebraically. Now explain how your graph confirms this. Well, right around 17, we have that intersection. So that is important for how my graph determines this. All right, the marathon problem. Elena is running the marathon. She researches training plans. Jillian's is 12-week, Josh's is 14, and the numbers are plotted below. Which one is arithmetic? Well, arithmetic should make you think add a constant amount. So here we're doing add, subtract, add, subtract, add, subtract. And that is not going to be arithmetic. Versus when I look at Jillian's plan here, we are linear in our growth, which means we are adding a constant change. So here I would say that Jillian's plan is arithmetic because it adds a constant amount each month. Now, to write a recursive definition. So recursive means recurring depending on the term before it. So we need the first term and we need the pattern for the nth term. So for Jillian's plan, the first term is 10. And then the pattern is take the term before it and add 1. Now, Jillian's plan has an alternative if Elena wants to train instead for a full 26-mile marathon. Each week would start at 13 miles and follow the same pattern for the half marathon, but would continue for 14 weeks. Write an explicit formula. That should always make you think, look at your formula sheet. So, AN is A1 plus N minus 1 times D. AN, I don't know, but that would be the initial plus N minus 1 times your common difference. And that right there would be your explicit formula. All right, next one, factor completely. I see 4 terms, so I'm going to do some grouping. First two, GCF is x squared. Take out a y minus 4. Second two, GCF is a negative 9 because your leading coefficient is negative, and that leaves me with y minus 4. And so this will be x squared minus 9, and then y minus 4. Now, always ask yourself, am I totally done? Which I'm not. So x minus 3, x plus 3, y minus 4. Now I'm totally done. And notice I am not setting those equal to 0. I am not getting a solution because, friends, this is not an equation, so we can't solve it, right? Okay. All right, next one. The solutions to the equation this in a plus bi form are what? Well, this is quadratic. Let's get it equal to 0. So 5x squared minus 2x, subtract the 9 over, that will be plus 4 equals 0. Now, spoiler alert, if it says a plus bi form, chances are there will be an I, which means we probably can't factor it over the real numbers. So I'm just going to use quadratic formula for this. So x equals negative b, which is positive 2, plus or minus the square root of b squared. Notice I have parentheses around that. Minus 4 times a times c, all over 2a. Now, let's simplify. Start with what's under the radical. Do not put the radical in your calculator, just what's under the radical. So that's 2 plus or minus the square root of negative 76 all over 10. Now, 76, well, okay, I know that's negative 1. And I can make a factor tree for 76. That's 2 times 38. And that's 2 times 19. So this is 2 times 2 times 19. So I can simplify this. I could say that's 2 plus or minus. Now there's a pair of 2's, and the square root of negative 1 is I, radical 19, all over 10. And so to break this up into a plus bi form, I just need to break it up so that it's two separate numbers. So 2 over 10 is 1/5, plus or minus 2 over 10 again is 1/5. And you could put the radical 19 over that. And then we need the I. So this is again a plus bi form. Okay, next one, 13. Express this in simplest form. So notice there's x's and i's. You cannot just throw this in your calculator. So we need to actually do the algebra out. So I'm distributing this out. So multiply, add your exponents if your bases are the same. So 2, x to the first times x squared is x cubed. I times I is I squared. Minus 2 times 3 is 6, xi cubed. Now let's simplify what we can. I squared, you can put in your calculator if you'd like to. 2x cubed times negative 1. And I cubed, you can put in your calculator if you'd like. 6x times negative I. And so this is going to be negative 2x cubed and then plus 6xi. That is as simplified as we get. All right, number 14, the graph of p of x is shown. If p of x is divided by x minus 4, what is the remainder? This is a question where we aren't going to be able to just write the equation and divide because I can't see like exactly where these cross over here. So let's start by thinking about this. If this is a factor, then I'm going to think about where that equals 0. So x equals 4 should be a 0, right? Well, maybe this won't be a factor, but that's at least the factor we're dividing by. So x equals 4. So let's look at when x equals 4. What's the value of the function? It is 8. Remember, we're finding p of 4 there. That's 8. And the remainder theorem tells me that the value of the function at that point is equal to the remainder when I divide by its corresponding factor. Okay, next one, the zeros of a quartic polynomial. That means it's x to the fourth, which means your end behavior is either up, up, or down, down. Are negative 2, 2, 4, negative 4. Now, they could have written this as plus or minus 2 and plus or minus 4. That would mean the same thing, right? Excuse me. There we go. Use the zeros to construct a possible sketch. So it's got to cross at negative 2 and negative 4. Notice I'm labeling them. It's got to cross at 2 and 4. And it's quartic, so it should have a multiplicity of 1 at each of those zeros. So cross, 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 cross. Or your other alternative, because it didn't specify about your leading coefficient, would be cross, 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 cross. Right? So either of those would work. Okay, next one, 17. Solve this. As soon as I see a fractional equation, I'm thinking LCD. So my LCD here, let's go through our denominators. The first denominator is t plus 1, or 3, sorry. The second denominator is t. The third denominator is t, which we have, and t plus 3, which we have. So I'm going to go through, and let me change colors for a second. I'm going to multiply each of these by t plus 3 times t, distributing that out to each one. So for the first one, I'm going to do 1 times t plus 3 over t plus 3, plus, for the second one, it's 2 times t plus 3 over t, equals negative 3 times t plus 3 over t times t plus 3. And now's the fun part. Now's when we get to cancel. So, cancel city. T plus 3's cancel. All that's left is 1t. T's cancel. All that's left is 2 times t plus 3. T's cancel. T plus 3's cancel. All that's left is negative 3. So I wind up here with t plus 2t plus 6 equals negative 3. 3t equals negative 9. T equals negative 3. Now I'm going to check that. Guess what? There's an error when we check. And so that means there is no solution. Which happens. That's okay.